So today, we're looking at a piece of tech that honestly sounds a little bit like magic. We're talking about pushing a full 8K video signal across the entire length of a football field.
Yeah, with no repeaters, no signal boosters,
Just one cable.
one single cable. It sounds simple, but the physics involved are pretty intense. We're looking at the NTI DP8K-FO-100M-MMLC.
Whoa, that's a mouthful of a serial number?
It's purely functional, but the mission here is really the amazing part. We're trying to move 32.4 gigabits per second over 100 meters.
Which is what, over 300 feet?
328 feet, to be exact, without losing a single pixel of information.
Right, and that's the thing. If I try to run a standard copper DisplayPort cable even half that far, I get
What?
Snow, a flickering mess.
If you're lucky, usually you just get nothing.
So how is this NTI cable pulling it off?
Well, it's not standard copper. It's an active optical cable, or an AOC. But here's the nuance, the part people often miss. It's actually a hybrid.
Hybrid? You mean it's got both fiber and copper inside?
Is it?
Okay, but why? If copper is the bottleneck, why not just go full fiber?
Because fiber is brilliant for data, just incredible. But for carrying power, it's terrible. So inside this tiny 5.2 millimeter jacket, they've split the jobs. The actual video data, all the high-speed lanes, are traveling over 4 optical fibers. That's how you get 8K at 60 hertz, or your 4K at 120 hertz, with what they call zero signal loss.
And the copper's just along for the ride?
The copper handles all the low-speed utility work. It carries power, and this part is crucial, the DDC, the display data channel.
That's the handshake protocol, right?
That's the handshake. It's your monitor telling your computer, hey, I'm here, and this is what I can do. You need that.
Okay, that makes sense. But I saw something in the specs. It says active cable, which to me usually means there's a clunky power brick you have to plug in somewhere. This one says no external power.
It is surprising, isn't it?
Yeah.
But it's becoming the standard for these high-efficiency AOCs. It actually draws the tiny amount of voltage it needs to power the optical engine directly from the DisplayPort interface itself.
Is there a catch there? What if I'm plugging this into, say, a low-power laptop? Could that be an issue?
That's a valid concern. If your source device isn't outputting the standard voltage on that pin, the optical conversion just won't fire up. It's a parasitic design.
But for the kind of gear this is meant for.
For industrial or professional gear, it's almost never an issue. No.
Speaking of industrial, the spec sheet really emphasizes its immunity to RFI and EMI, radio and electromagnetic interference.
Which is absolutely mandatory for who they're selling this to.
Yeah.
Think about it. If you run 300 feet of copper through a ceiling in a hospital or a factory, that wire basically becomes a giant antenna.
Picking up all sorts of noise.
Noise from every motor, every light ballast, every MRI machine nearby.
And then your surgeon's monitor goes black in the middle of a procedure.
Exactly. Or you get artifacts on a critical display. Since the video data in this cable is traveling as light literal photons, it's completely immune to that electromagnetic noise.
That's why they list things like medical imaging and airplane onboard video as use cases.
Yep. And it also operates from -40 all the way up to 158 degrees Fahrenheit. It's tough.
So it's built like a tank. But there's a software layer here, too. It lists HDCP 2.2 compliance.
And that connects right back to that hybrid design. You might get the video signal across a long distance, but if that HDCP encryption handshake times out because of the resistance...
You get a black screen on Netflix.
Black screen, no protected content. This cable has to actively manage that digital handshake to make sure it all works.
I'm guessing that active management is why this thing is directional. You have to check which end is labeled source and which is display.
Oh, you absolutely do, please. Can you imagine routing 100 meters of this through a wall or a conduit and then realizing you plugged it in backward?
That sounds like a very, very bad day.
The signal only goes one way. You'd be pulling it all out again.
A very expensive day. Which brings me to the price. This thing is about $330 for one cable. That stings a little.
Context is everything, though. If you're hooking up a game console in your bedroom, yes, it is complete overkill. But if you're outfitting a professional broadcast station or a huge digital signage rig,
it's just part of the cost of doing business.
It's a rounding error compared to the cost of a blank screen during a live event. It's really an insurance policy for your signal.
So a professional tool for a professional job. We're talking 8K, 4.4.4 color, massive bandwidth, all flying down a thread of glass.
It really illustrates a fundamental shift in how we think about something as simple as a cable.
How so?
Well, we used to think of cables as just, dumb pipes, just wires. But this thing is an active hybrid device. It's managing electricity, light, and data simultaneously. It's negotiating encryption keys in real time.
It's basically a tiny, specialized computer.
Exactly. So it makes you wonder, if our cables are becoming this complex just to move video around, how long until the whole idea of a dumb pipe is just gone?
That's something to think about next time you plug in a monitor. Thanks for joining us for this deep dive.